No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Dr. William Springer. He has written a wonderful book called A Programmer's Guide to Computer Science, a virtual degree for the self-taught developer. How are you, sir?
Great, Scott. It's really nice to sit down with you.
It is nice, and I appreciate it. We've been talking about doing a podcast for a while, and I'm glad to have you on the show right now. I also want to point out to folks who are listening that you happen to be talking to me via an induction loop. Is that correct? I'm being piped directly into your ear?
Well, through my cochlear implant, yes.
Through your implant?
Yes, you see, Scott, my issue is that I have really bad, I guess I would say, discrimination, where I have trouble picking out some sounds from other sounds. So if I was, say, to be listening to your podcast, if I just played off the computer speakers, I would most likely not be able to understand you. And so what I do when I'm listening to something is I just plug directly into my implant, and that way I can hear what's coming out of my sound system and nothing else.
Well, I appreciate you taking the time to hang out with me on a podcast, which may not be a natural place for you to spend time. And I also want to point out to my listeners that I did for many years have transcripts, and I am currently looking for a corporate sponsor. The transcript company I was using to create written transcripts went out of business. So if you're interested in sponsoring Hansel Minutes, I want to go and make transcripts for all 750 episodes, both forward and backwards. So I've always wanted to continue to do that. Unfortunately, those transcripts were lost, and hopefully we'll do that again. All right, to the show. You have written Volume 1, which I purchased and I have read. And I understand that you have Volume 2 coming out on a virtual degree for the self-taught developer. That's coming out quite soon?
Yeah, I actually have. The first half of it just got back from my content editors with my copy editor now, and the second half will be going this month. So I'm expecting Volume 2 to be out probably next month.
That's great. Let me ask you this. What do you think the difference is between a computer scientist and a programmer, and why do we have those two separate terms?
Well, Scott, the thing with computer science is you don't actually have to have a computer to do it. Okay? When I was working on my degree, I was at CSU, Colorado State University, and that's mostly a very applied program. So we had a lot of people who are doing all kinds of programming. They're running tests on BGP-Mon, all kinds of stuff like that. I was actually a theorist when I was there. I was working on graph theory. I think I needed to write 3 programs in 4 years. Because what I was working on is I just had to sit down and draw pictures and think through things. Because the idea of computer science is we're figuring out what computers can do and how to make them do what we want. And then, at least for what I was doing, the programming language is just a tool that we can use to prove our results. So I would prove I can do something, and then I would actually go and write a program to do it. But the program isn't the interesting part. The interesting part is actually figuring out the logic that shows this is how you can accomplish what you're trying to do.
Interesting. Would you then say that programming is applied computer science?
Yeah, I think that would be one way of looking at it. And that was actually kind of partially what led me to this book, is showing people who are programmers and they don't have that computer science background, how they can take that and apply it to what they do so they can make themselves be a little bit better at programming.
Yeah. You pointed out in one of your blog posts from 2016, I will link to it in the show notes, that in a Stack Overflow developer survey, a quarter of developers did not study computer science. A lot of developers do not know computer science. I think today in 2020, it's even more true that you can be a very successful programmer without a formal education. Do you think that's a good thing or a bad thing?
Oh, no, Scott, I think that's a great thing. That computer programming in many cases of a meritocracy. We want to know, can you do a good job at programming? And if you can, then you don't necessarily have to have the degree to do that. At the same time, I do think a degree has a lot of value, because it gives you an idea of, how people have figured out ways to approach problems, so that you don't have to reinvent the wheel every time. You already have an idea of approaches that you can take, so that when you run across a problem, you have an idea of how to solve it.
Mm-hmm. But you actually point out in your blog post that the computer science class doesn't necessarily teach you to program, and some people can't afford it. For some people, it's not how their brain works. So you want to make them successful and give them information that enables them to be good programmers without requiring that expensive undergraduate degree.
Right. Obviously, I do have the degree, and I felt that it was definitely worth it for me. Not necessarily from a financial perspective. I don't mind telling you I'm still paying for my PhD now, paying off my student loans, but just because I find that kind of material very interesting. Just to take an example, if you look at sorting algorithms, for example, and you can take some sorting algorithms for some problems and get O(n) runtimes. And I just think that's really fascinating.
But that doesn't make me a better front-end JavaScript developer, or does it?
I found that the vast majority of the time when I'm at work, I don't need the stuff I learned in computer science. I found it useful stuff. There are occasions where we get to things more complicated, and that's like, oh, you know what? This is kind of a special case of this general problem that's known in computer science, and I can take this algorithm that we know about and tweak it a little bit so it meets our needs.
Mm-hmm. At the very beginning of your book, you have a section that's called When Seconds Don't Count, and it's right after the section Why Speed Matters. And it was interesting because you start out and you're making a robot that makes sandwiches, and then you say, here's why speed matters. And then you say, well, maybe it doesn't matter. Let's talk about what this robot's doing. Maybe it can do two things at once. Maybe we're not thinking about this the same way. Maybe squeezing milliseconds out of a sorting algorithm isn't always what we need to be doing.
And I've had occasions where, I'm doing code review and somebody's trying to do something the most efficient way possible. And I say, you know what? It's not worth getting this optimized right here because the way you're doing it, it's hard to read. It's going to get us more likely to have bugs in the future. Let's just simplify this code and make it more understandable because it's in a section where if it takes a little longer, nobody's going to notice. It doesn't matter right here. And then we have other parts of the code where it's like, okay, we need to transfer, gigabytes of data as quickly as possible. This part of the code absolutely has to be optimized the best way we can possibly do it.
One of the things that I liked about your book was as I was reading, and it was easy to read, and then an equation showed up, and I was like, uh-oh. And then you had a section that says, math alert, and it was almost a warning of like, okay, here's some math, and let's talk about that. And it kind of made it more inclusive. I didn't do a lot of advanced math in school, and I felt comforted that the book warned me that the math was coming, had a nice clear graph, and then went back into the code. So I didn't get scared away.
Well, that's good to know, Scott. My challenge when I was writing this book is that normally when I write things, I'm writing to an audience that's like me. I'm usually my own audience. And in this case, I'm not, because I was writing this book and I'm aiming at people who don't have that background. They don't have a degree. Maybe they didn't go to college at all. They, it's smart people. They know how to program. They understand computers, but they don't necessarily have the background where they'd be able to pick up your typical computer science textbook and actually be able to get something out of it.
Was that hard for you? You have an advanced degree. You have a PhD. So you have 3 degrees, if you count your master's and your undergrad, all in computer science. You had to put yourself in the mind of someone with no degree.
And it was a challenge, Scott. When I first started on this, I think I started writing this book about 2016. And I wrote, the first few chapters, and I pulled in some beta readers to give me feedback. And at the time, they were telling me I was writing this at too high a level. I was demanding too much from my readers. It was just too complex for my audience. So I had to really go back, and I actually spent a couple of years just going back over this and rewriting it. I don't want to say, dumbing it down, so that's not what I'm doing here, but just trying to be as clear as possible and avoid assumptions. Avoid using jargon, avoid assuming that the audience has a particular background that I would have been used to when I taught college.
I've never liked that term, dumbing it down. I prefer making it accessible.
Yeah. So, so now I looked at this and, you can tell me if I hit the mark here, but I tried to write this in such a way that the reader would never feel that I was talking down to them, but that I was just explaining in a way that meets them hopefully at their level.
Mm-hmm. Yeah, I think you succeeded in doing that. And I really enjoyed the parts of the book where you step back and put something in a box. For example, you were explaining linked lists, and then your professor said something, and then you can step aside and say, well, this was kind of silly, and I don't think this is how this works. Those little moments where you are going down the straight narrative, and then you step aside for a moment, I found made the book easier to read.
And one thing I was doing for sure when I started this project is I was trying to figure out, what can I do as a side project that would take advantage of my unique background. So I looked at me and I'm like, now I'm a software developer. I used to be a textbook editor. I've been a middle school and a college teacher. I used to write for magazines. So I'm looking at all that and I'm like, okay. I like to explain things to people. I like telling stories. I have this background in computer science. So why don't I write something where I can explain how these things work for people who would be interested? And then I can, throw in little stories about how I actually used it here and there, or how something applies in a way that maybe you might not expect.
Are you struggling to create the applications your business needs at the speed that they demand? You should take a look at OutSystems, the most complete application development platform for building enterprise applications fast. With OutSystems, thousands of happy customers are tackling their app backlogs and quickly creating enterprise-grade web and mobile applications that evolve and scale with their changing business. You can sign up for an OutSystems personal environment today and build your own applications. It's free forever, and you'll get your first app built in just a few minutes. Learn more at outsystems.com/developer-media. That's outsystems.com/developer-media. How did you know which sections to be long and which to be short. I was surprised that some of the sections were quite short. For example, you're talking about sorting, different kinds of sorting algorithms, and entire books have been written on sorting algorithms, but you were quite crisp. You explained exactly what needed to be said, and you didn't waste any words.
I wish I could tell you that I had some fancy method of deciding it, but what it came down to was just I opened a session and I figured this is what I want to say about that, and I said it and I was done. What was nice is, I wasn't really trying to hit any particular page count. My goal here was to give the reader enough material that they understood the basics of it, that they can carry on as part of a conversation that touches on this, but I'm not making any attempt to be comprehensive. I'm not giving you mathematical proofs that you have to sit down and work through for a half hour. I'm just trying to keep it moving along. So in each session, I'm basically saying, okay, here's what I think are, the most important things I have to say about this, maybe an example to clarify it. But once I've done with that, I'm done. Let's move on to something else.
That's a really good point, and I appreciate that you said that, because that gets back to the concept of accessibility, where someone's in a conversation at work and someone with a computer science degree talks about order and complexity. And that's not an accessible term for someone who didn't do that in school. And what you're trying to enable them is to be a part of that conversation.
Right. So, you read this and now you're like, okay, I understand what big O analysis does. Maybe I don't know how to actually determine the big O runtime of something, but if you tell me, this is linear, this is quadratic, now I have some kind of conceptual framework for what those terms mean. So I'm not getting lost wondering about that while you're going on to something else.
Here's a small side question. I was looking at chapter 5, which talks about data structures on graphs. Why do you think that computer companies, Google, Microsoft, Facebook, seem to think that the binary search tree is the question we should ask someone and make them do it on a whiteboard? Why is that the gate that we force people to come through if they want to be a programmer?
No, Scott, I'm going to give you a two-part answer to that. The first part is that I have never interviewed anybody, and I don't make interview policy whatsoever. The second part, you may have noticed that I think I spent a fair bit of time on graph algorithms in the book, and the reason for that is almost everything in computer science comes down to graphs. You've got all these different problems, and just so many things it comes back to, what? I can take this, and it's really a special case of this graphing algorithm. And it's just really amazing how many different things you can model. So I would say that, a binary search tree is one of the more basic graph structures, right? If you've had at least some graph theory, you're probably familiar with binary search trees. You probably know how to use them, but it's not something esoteric like a red-black tree or something where, unless you're doing that type of work, you've probably forgotten all about it, even if you ever knew it.
That's actually a pretty good answer. While I still feel myself, it's my opinion, that making people write on a whiteboard is kind of difficult. I'd rather that they do natural work. I'm hearing you say that graph structures are the next obvious thing after a list structure, and they are really fundamental when you're working at anything at scale. So they are a useful thing to know, and that's why you spent so much time on them.
Mm-hmm. Well, to be quite honest with you, Scott, part of the reason I spend so much time on them is just I find them interesting. So, this book is really is a reflection of what I think is interesting about computer science. And I think, or at least I hope that makes the book more interesting to the readers, because I'm not just going on and on about trying to hit every little detail of these topics. I'm saying, okay, here's something I think is interesting about this.
Mm-hmm. But you also have volume 2 coming out soon. What was not in volume 1, and what is volume 2 a continuation of? What is it going to include?
Well, see, here's the thing. When I first started doing this, when I sent it out to my beta readers for opinions, I had the table of contents set up, and this was all going to be one book. I was not inclined doing multiple volumes. And what people were consistently telling me is, there's too much information here. This is intimidating. I looked at this and I'm frightened by it. So what I did is I went through, basically right up to, I think, Turing machines. And this book just pretty much covers what you would expect to find in a junior level course on Foundations of Computer Science, which is a course I used to teach. So I did that because I thought, okay, this is the stuff that I think is most likely to be relevant to you. And then everything that was coming after Turing machines, I chopped off. But I said, okay, here's things like, artificial intelligence, quantum computers, network chain databases, where it's still relevant, it's still interesting. It's maybe less likely to come up in your day-to-day work or in a job interview or your typical conversations. So my goal was pretty much that volume 1 would be as accessible as possible, and it would give everybody the most useful information. So if you only read one of the books, you pick up volume 1, this is going to be the thing that's going to be the most useful to you. And then volume 2 would be those topics that are a little more advanced, a little more specialized. So people who just want a quick introduction, they can take volume 1, they can be done. It's complete. They don't need anything else. And people who want to go a little bit further, they can pick up the second volume.
Do you think you have a third volume in you?
Yes and no. So volumes 1 and 2 together are the book I wanted to write. That's the whole thing I want to write. I'm interested in writing about other topics, and I actually have 2 books in mind that I'm thinking about writing. I'm thinking about writing a book on accessibility. As you know, I'm deaf, and I have spoken on accessibility at a few conferences, mostly in terms of making websites accessible for blind people and a little bit for deaf people. I've considered writing a book about that. And I've also considered writing a book about enterprise software development. Because if you look at this book, this is computer science for programmers. So I've thought about also going the other way, a book about programming for computer scientists.
You've had a blog on and off for 10 years, but it sounds like you've spent more time now recently putting your keystrokes into the books, and that's a more effective use of your time?
I always mean to update my blog. I think my problem is I'm a little bit of a perfectionist. Like I said, this volume 1 here, this took me about 3 years to write. Part of that is that my wife got pregnant right when I started working on it. But a part of that is just that, once I wrote it, I kept revising it and trying to make it as good as I could possibly make it. The other thing is just that, when it comes to blogs, sometimes I don't necessarily know what it is that I want to write about. I think, a lot of times that's what it comes down to is, I sit down, I'm like, I have no idea what I want to say today. And whereas with the books, first thing I did is lay out a table of contents. I'm like, okay, here's a lot of things I would like to talk about. And I just spent the next year filling that out.
Mm-hmm. One of the blogs that I'm going to put in the show notes is the one that was called The Value of Computer Science Education for Programmers. It feels like that might be one of the blog posts that got you writing this first volume.
Yeah, I mentioned this guy. I started going to programming conferences a few years ago. Mm-hmm. And what I've noticed at those conferences is that there were a lot of people who have the programming background. They work as developers. They don't necessarily have a college degree, but they would like to learn. Yeah. And I started giving talks in that area. I gave a talk on sorting algorithms, a talk on graph theory. And I found that, people were showing up and they were paying attention, which is nice. And so that was part of it. And I see it, there's a lot of discussions on the internet where people say, oh, degrees are worthless, right? It's a waste of your time. It's a waste of your money. Just go join an open source project, GitHub, and build something. And I wanted to, this partially me being lazy, is if I get sucked into a conversation like that, I just wanted to be able to just drop a link and say, okay, here's what I think about this. Here's why I feel that, yes, you can be a fantastic programmer without knowing computer science, without getting a college degree, but here's why I think it can still be useful for you.
That's great. And you also point out that while as a software developer, your job involves writing code, it's not all aspects of software development. There's testing, creating designs, looking at other designs, writing documentation, how explaining to end users. Programming really is about communication. So I'm hearing you say that you're an advocate for a well-rounded education for a computer programmer.
I saw a question recently, I don't remember where it was, but somebody asked, what's a good skill for a programmer to have? And my answer was that's helpful if a programmer has a good writing ability, good English, because you need to be able to explain to people what it is that you're asking the machine to do. It's like you were saying, yes, I write code, but then I write help tests for the end user. I write test instructions for my tester. I write a sign that says what's going to happen when I actually do the code. In fact, my experience has been that when I'm doing some development, if we run into problems while testing, the cause is almost always that it wasn't specified well enough when I did the design.
Interesting. Someone told me once that if the specification were clearer, it would be code.
Right. So that code is basically a design written in a programming language, right? But sometimes we have a tendency to just say, okay, here's this problem, and here's the broad strokes of how I'm going to fix it. But then there's some little details that are kind of important, but you don't get to them, or maybe you just don't know about them until you start digging into the code. And the result is that there are decisions that need to be made, and they're actually impacted by your business logic, your higher level policies. And if you don't know about those decisions when you're doing your design, if you don't put them in the design, then you may end up doing the wrong thing in the code and you have to backtrack.
And that sounds like this maybe future book that you have in your head about designing business software, because those things about fundamentally understanding requirements, expressing them at scale to a group, that's a skill that I don't remember learning in school.
Mm-hmm. And I feel like being, right now, I'll tell you, I work in a company. We have thousands of developers. We have, I assume, millions of lines of code in our product. And then you compare that against being in school, and you're working by yourself or with a couple other people. You're writing programs in a semester at the most. It's a big difference in scale, right? And I feel like you don't necessarily learn things like how to do consistent style that other people can read, how to be checking in your code, all those skills that are not necessarily important when it's just you by yourself working on a program that's maybe a few tens of thousands of lines of code versus you with dozens of other developers working on a massive system that's been under construction for a couple of decades.
What is your opinion when it comes to the programming language of choice? There's always people that talk about their favorite programming language and the one that they know, their most favorite, the language of their soul. And then there are the people who say, you should be a polyglot and you should know as many languages as possible, or you should learn a new language every year. Where do you fall in that argument?
Mostly I fall in the class of people who hate JavaScript.
Yeah, so any language but JavaScript.
So you know what, Scott? I've been in the same job actually for 9 years now, which I know is a long time for a developer. I just like what I do. And when I started, they had some programming assessments, and they said, use any language you want. We don't care. And when I started, I didn't know any of the programming languages they use. I just picked them up as I needed them. So I've gone through, I don't know how many programming languages in the last 9 years as I was working on different things. I was doing some SQL for a while, so I picked up SQL Server and Oracle. Right now I'm doing web-based stuff, so I'm using C# and TypeScript. I will tell you C# is my favorite language. I'd rather work in C# than anything else, but I've never really felt like there's got to be one language I gotta use for everything. I think there's value to learning multiple different languages and seeing how they approach things, but I'm not one of those people who feel like they have to be learning new languages all the time. For me, a language is a tool, so I'm only going to pick up a new language if I have a reason to do that. I have something I want to do, and this language is the best way to do it. That's a reason to do it, but I don't see language learning in itself as something that I'm interested in.
Well, thank you very much for chatting with me today.
It's been a pleasure, Scott. I'm glad we finally managed to sit down together.
I appreciate that. We have been talking with Dr. William Springer. He is the author of A Programmer's Guide to Computer Science, a virtual degree for the self-taught developer. Volume 1 is out now, and Volume 2 will be out any minute. You can pick those up at Amazon and on his website. I'm going to put links in the show notes. This has been another episode of Hansel Minutes, and we'll see you again next week.